of PCI bus as a standardized I/O interface. So PCI stands for Peripheral Component Interconnect, and it is one of the most widely used I/O interface. And this is how PCI fits into a computer system. So here the host is our processor, and this line indicates the processor bus. So PCI actually is directly connected to the processor bus of our system, or in short, PCI acts as a mediator between the processor and the rest of the peripherals in the computer system. That can be one of the roles which PCI can play. So PCI bus actually has got two parts. One is the PCI bridge and the other is the bus itself. So PCI bridge is the circuit component which actually interacts with the processor bus and with the other devices, so that the protocols used by the devices to communicate with the PCI bridge can be converted to the processor bus protocol. Or in short, this PCI bridge is a integrated circuit that translates between the PCI protocol and the bus protocol followed by the processor or the host. So PCI bridge is an important component. Now we will see what are the major features of PCI bus. So the first feature of PCI bus is regarding the transaction or data transfer that happens using that. Okay, each data transfer in PCI bus is known as a transaction, and a transaction is composed of number of phases. So if you see here the transaction between the host and the printer involving PCI bridge, here the transaction is indicated using an orange line, okay, composed of many sub-components or sub-lines. So this entire orange line or this entire orange color indicates a transaction, and the breaks or linkages within this orange line, okay, or there are three linkages within this orange line, right? So these three linkages indicate the various phases of this transaction. Okay, so this entire transaction is called as one burst, and the within one burst we can have multiple phases. It might be usually 2 or 3 or 4 phases depending upon the bus size of the PCI bridge. Okay, then in another thing about the PCI bus protocol is the master is usually designated as initiator, or it is called as initiator, and in the slave is usually called as the target. So instead of master slave terminology while discussing about PCI, we may use initiator and target terminology. So that is another important thing. And another major thing regarding the bus protocol followed by PCI is PCI follows a mix of synchronous and asynchronous protocols. So even though at some point of time it may act as per a synchronous bus protocol, but at many other instances it is purely asynchronous. Okay, so PCI has got the best of the both synchronous protocol and asynchronous protocol. And this table shows some of the data transfer signals used during a PCI data transfer. Note that in these signals, wherever the name is followed by a hash, it indicates an active low signal. Okay, so the first is the clock signal itself, which gives the PCI its synchronous nature. So if you see this timing diagram shows a typical PCI data transfer. Here it's a read operation. So you can see that the clock signal actually controls the various phases or parts of this entire transaction. Okay, this clock signal is spread throughout this entire transaction. Then the next important signal is the frame signal, and if you consider the frame signal is actually initiated by the initiator, and it actually indicates the duration of a particular transaction, or it is actually what produced by the master to indicate the duration of a transaction. And if you see the case here the burst of the transaction is composed of 4 parts or 4 phases, and the frame signal is extending up to the third phase. Okay, so the frame signal is like that. If the number of phases in a transaction is n, the frame signal extends up to the n-1 part of the transaction, or n-1 phase. Okay, so that is the role of the frame signal. Then the next important signal is AD, or the address data signal, or address data line. So this is another important feature of your PCI bus. In case of PCI bus, the address and data lines are multiplexed, or it means that we don't have separate address and data lines. In order to reduce the size of the PCI connector, and in order to compact the things, PCI designers have chosen for multiplexing address and data lines together through common setup lines. Okay, so this AD signal or the AD line actually carries the address information during some parts of the transaction, and during some other parts of the transaction it carries the data part of the transaction. So that is about AD. Then C bar B. So C bar B stands for command bar byte enable. So C bar B or command bar byte enable actually transfers two types of signal. One is the command signal, and for normal case or normal operations it will be either a read or write signal to the target, and the byte enable is another signal given to the target from the initiator to indicate that which all parts of the address data lines has to be used for data transfer. Okay, so the two aspects of data transfer is actually transferred to the target from the initiator using C bar BE line. The first aspect is the command or what operation is going to happen. Then the second aspect is regarding how many of the AD lines or address data lines we are going to use for the data transfer. Okay, so in our assumption of the PCI bus discussion we are doing here, we are assuming that we have a 32-bit PCI bus, right, and it can transfer four 8-bit phases in one transaction. So it means that we are talking about 4 times 8. It means that we are going to have 4 phases within a transaction. So the byte enable, it has to enable all the 32 bits of the AD line. Okay, so the byte enable signal will be set like that. Then the next signal is initiator ready and target ready. Actually this indicates the readiness of the devices. It is just like our master ready and slave ready in case of asynchronous protocol. So more or less initiator ready and target ready actually provides asynchronous nature to the PCI bus. So note that synchronous nature was provided by the clock signal, which we will see how we will alternate between the synchronous and asynchronous nature of PCI bus in the coming discussion. So asynchronous nature to PCI bus is given by the initiator ready and target ready. Initiator ready is activated whenever the initiator or the master, right, or the CPU is ready to accept or give data to the PCI bus, and target ready is activated by the target or the slave whenever it is ready to read or write data as told by the master. Then we have another important signal regarding data transfer, that is device select. Device select signal is actually activated by the slave or the target whenever it has performed the address decoding as part of a PCI transaction, and whenever it is ready to accept data or give data to the master or the initiator. Now another signal regarding data transfer is initialization device select, and it is mainly used in the configuration phase of PCI, and we will discuss that in the coming discussion. So these are the main signals used in a typical PCI operation. So we will see what these signals play, what role these signals play in a typical transaction. So we are going to perform a PCI read operation, and here the assumption is the initiator is the CPU and the target is a device, maybe like a RAM. So the clock cycle will be running, and we have around 7 clock signals here. And in the first clock signal, always the operation is the master or the CPU will put the address of the device which it expects to respond, and the command for the device is also put in the first clock cycle. So in first clock cycle it is entirely a synchronous operation, or the role is clearly defined what has to be done for first clock cycle for the master or for the initiator. So in the first clock cycle, always the initiator is supposed to put the address and command meant for the target or the slave. Then again the operation is clearly defined for second clock cycle of a PCI transaction, and in the second clock cycle what is expected is the master should relinquish control, or the initiator should give away the control of the AD line or the address data line to the slave or to the target. Okay, so by the second clock cycle, slave or the target will have control of this AD line, and from second clock cycle onwards, no more address can be put into AD line. It will be entirely used for data transfer. Okay, dependent upon the BE or the byte enable. Okay, certain lines can be left off and not be used for data transfer, so it will be fixed by the initiator based on the B signal given from the second clock cycle. Note that from the first clock cycle itself, we are starting the transaction, so this initiator will depress the frame signal to indicate the start of the transaction. Okay, so we have covered the first clock cycle where the initiator has depressed the frame signal to indicate start of the transaction, and address of the slave or the target which should respond is also put, and the command to the slave. Here we are performing a read operation that has also been given, and it is put towards the end of the first clock cycle. So the first clock cycle operation is clearly defined. Then again, in the second clock cycle, the main operations are transferring the control of the address data lines to the slave, and then the slave is supposed to get ready for the data transfer operation requested by the master, and also initiating the byte enabled signal to inform the slave which all lines of the multiplexed AD line it is supposed to use for the data transfer. So these are the main duties in the second clock cycle. Okay, now from the third, fourth or fifth clock cycle, it is entirely up to the slave or the target to decide when it should start the data transfer. So the starting of the data transfer by the slave or the target is indicated using the target ready signal. So here you can see the target ready signal. So after the second clock cycle, it is up to the slave to activate this target ready signal to indicate the start of the transaction. So here the assumption is the transaction immediately, or the data transfer immediately starts at the third clock cycle. So if you see the third clock cycle, along with the data being put, or the first phase of the transaction being put by the target, we can see that the target ready is also activated, and the master or the PCI master, on seeing the target ready, will also activate its initiator ready to show the target that it is receiving the data it has put on the bus. Okay, so here the third clock cycle is entirely asynchronous in nature. What happens is the target will put the first phase of the transaction or the first part of the burst onto the AD bus. Along with that, it will put target ready to indicate that it is actually putting valid data, and the initiator, upon seeing the target ready and data, will put initiator ready to indicate that it is receiving the data that the target has put. And one more thing regarding the second clock cycle, if you see the second clock cycle, we have understood that the control of the bus or the AD lines have been given to the target, right? So the target is now ready for data transfer. So that is indicated by another signal known as device select. Okay, device select indicates that this target is now having the control of the bus or the AD line, and it has been selected by the master to maintain AD line as long as this transaction is going on. Okay, so device select will be on till this transaction ends. Okay, so we have now seen the beginning of the third clock cycle, or the first phase of the transaction. Now if you see the fourth clock cycle, again the second part of the burst is being dispersed, and so what happens, initiator ready as well as target ready is remaining depressed, as well as the device select is also getting depressed. This happens till all these things happens till the third clock cycle. But what happens in the third clock cycle, not in the clock cycle, what happens in the third burst transfer, or in the third part of the burst, what happens is we are going to near the completion of data transfer, right? So as I told earlier, the frame signal will be depressed towards the n-1 component of the burst. So this burst is having 4 components, and the n-1 component is the third component, right? So towards the third component, what happens is the frame signal will be depressed or deactivated to indicate to the slave that the slave is supposed to close the transaction by the next transfer or the next phase. Okay, so only the frame signal is depressed in the fifth clock cycle. Then we will see about the next thing. right? And the next part is also an asynchronous nature thing, or the part immediately after the frame depression. So immediately after the frame signal is depressed, some duties are lying with the master as well as the slave, or the initiator as well as the target. What the target should do, by the closure of the frame signal in the next clock cycle, the target should send the final phase of the transaction, and the target should be ready to depress its target ready signal towards the end of that clock cycle, and so will the initiator depress its own initiated ready signal towards the end of that same clock cycle. Okay, and again device select signal should also be depressed, so that it indicates to the master that the entire transaction is complete and this device has relinquished or given back the control of AD lines back to the master. Okay, so these orange mark clock cycles are actually the asynchronous, or actually indicates the synchronous nature of this transaction. So the first orange, or the first clock cycle, is for setting address and command. Second clock cycle is actually used to give control of the bus to the slave or to the target, and the immediate clock cycle after the depression of the frame signal is used to prepare for the end of this data transfer. Okay, so these are the main things that happens during a PCI operation. Now we will see what happens when there is some pause or there is some error during a PCI operation. So at that time, this asynchronous nature of PCI operation will actually help the devices. Okay, the devices can communicate with each other using these asynchronous signals, that is initiator ready and target ready, and can resolve the problem. So we will see such a thing. So here again the read operation is repeated. So the duties of first clock cycle and second clock cycle, it is exactly as it is, as we have discussed earlier. And here also the assumption is that in the third clock cycle the transaction starts, and what happens here is the problem occurs within the fifth clock cycle, or when the third phase starts. Okay, so here what they have simulated, or the others have simulated here, is when the third phase starts, the initiator is unable to complete the third phase, or it is not able to buffer the contents of the third phase into itself. Okay, also it is missing the data. So that is indicated by initiator by depressing the initiator ready signal. Okay, so what happens in the fifth clock cycle? In the fifth clock cycle, the initiator was supposed to take in the third phase into itself, but it is unable to do so due to some error at its side, or due to some corruption, data corruption. So it is indicating that immediately using the initiator ready off signal. Okay, so that is witnessed by the target. So what the target does is, it won't pull away the third phase, it will maintain the third phase as it is. Okay, so note that from clock cycle 5 the third phase is existing or kept into the bus as it is, so that the initiator can completely take it in after some time. So here again the assumption is, by the starting of the sixth clock cycle, the initiator's problem has been resolved and it has already taken in the third phase. Okay, so note that towards the beginning of the sixth clock cycle, initiator is okay with its problem, and it has read the third phase into it. So what happens is that initiator indicates that using an active initiator ready signal. Okay, and your target is also witnessing that. And note that as I told you earlier, the initiator will pull away the frame signal when it is in the n-1th phase. Okay, so here in the clock cycle 6, the initiator has completed reading phase 3, or the n-1 phase of the transaction. So initiator pulls away or depresses the frame signal in clock cycle 6. Okay, so this is the another thing that happens due to the asynchronous nature, or it is another helpful thing that happens, right, due to the asynchronous nature of this protocol. And proceeding further, what happens is, again they have made an assumption that by clock cycle 6 the target is not ready to supply the fourth phase of the transaction. There is again some delay with the target. Okay, now the delay is with the target in the 7th clock cycle. So what happens is, the target is going to tell that to the master or to the initiator by depressing the target ready signal. So the master sees that, and what the master does is, the master will wait for the target to become ready again by putting the byte enable as it is, okay, or it will maintain the byte enable as it is, so that the target can come back and work, right? So the byte enable is actually kept on in the 7th clock cycle, and what happens is towards the beginning of the 8th clock cycle, the target will be ready with the 4th phase or the 4th pulse of the transaction, and it will be given to the initiator. Okay, so the target ready will be activated again during the clock cycle 8, and what happens, initiator will read that, and this transaction completes by 8th clock cycle's end. So by towards the end of the 8th clock cycle, all the signals that have been keeping this transaction live dies. That means device select, target ready, and initiator ready is depressed. This is how a particular transaction happens.